Okay, so today is technically the first chapter. What you did before, that was called the prerequisites chapter. So all that stuff you did before was based on stuff you'd already learned. Okay, I know some of it was new for you, but that was all the prerequisites chapter in the book. So this is actually where chapter 1 would start in the book. And chapter 1 is about just functions and understanding what functions are. We're also going to be talking about their domain and range. We've already talked about that a little bit in our review. And then some transformations on the functions, like moving them around and stuff. So, do you remember that one? Absolute value. What's the one that looks kind of like that except it's curved? It's more of a parabola shape. What's that one called? Squared, yeah. Okay, so these parent functions come in a lot. And so there's some you should know by heart. You should know that guy. It's x squared. How about that one? Square root. Yep. It looks like this. Okay. And if you have a function like this, you should be able to tell me, oh, yeah, that thing's a parabola, because of the squared, that's been moved. What's that? Right 5, and what's that? Up 6. I want you to take notes on that right now. Would you please copy that one down and write in what each thing means? This little squared means it's going to be a parabola. This means right 5. This means left. No, not left. Up 6. All right. Other things to remember. Remember that the stuff on the inside is always counterintuitive. Because, see, minus 5 should be going to the left, because that's where the negatives are. But it's going to the right. The stuff on the inside does the exact opposite of what you'd expect. And we did a lot of this last year, so I'm expecting this to be pretty fresh in your mind. Give me a 5, 4, 3, 2, 1 on 5. This is pretty fresh. I'm pretty good on this. Or down to, oh, okay, good. I'm seeing a lot of 5s. All right, so don't forget, the stuff on the inside does the opposite of what you'd expect. The stuff on the outside, either in front or in back, the stuff on the outside is stuff you would expect. All right, domain and range. Do you remember that domain is like this way? Like how far will a function go that way, and how far will a function go that way? Okay, that's domain. You remember that? All right, if you looked at this function, assume there's arrows on it, and it's going to continue as it is. Do you get how, even though generally this thing is going up, that we could say that it would go forever to the left and forever to the right? So this guy's domain would be negative infinity to positive infinity. Because if I extended it out way over that way, it would eventually go all the way to infinity that way. All right, how about the range? Would you please, on your paper, write down what you think the range is, and I'll tell you if you're right or not. Please write down the range. Give it your best shot. Put in a little parenthesis in a bracket or whatever you need to make it work. I want to know honestly how many people get it right. That'll tell me how much review I need to do. It's not like you're a bad person if you get it wrong. I just need to know. A lot of people are knowing it or not. All right. Now, if domain goes this way to this way, range would go this way to this way. And how far does it go down? It stops at negative in 50. Not in 50, negative 50. And it goes all the way up to infinity. And these always need a curve because you'll never get to infinity. And this looks like it touches negative 50, so I need a bracket there. Raise your hand if you had it right. That's the vast majority, so yes, good. We're moving on. All right. So what if I asked you the domain of this but didn't give you a picture? Well, yes, you could just graph it, and you could look at it and say, okay, I know what that looks like. It's a parabola. It's a parabola. It's been starts here, and it's been moved which way? Right 6 or right 5, up 6. There. And now I can do my domain on it pretty easy. I look at it and I say, how far left would it go? Negative infinity. How far right would it go? Positive infinity. Okay, but do you have to have the graph? No, you don't. And here's how you can do these without the graph. Because sometimes you're not going to have a graphing calculator, and sometimes you won't know the function. You won't know what it looks like. Like, for instance, if I gave you this and said, what's the domain of this? Y equals 2 sine x over cosine of x. You probably have no clue what that looks like for a graph. I don't even know what that looks like for a graph. but I could tell you what its domain is. All right, so let me show you how. What you ask yourself is, there's only, domain just means, like, what are the numbers I can put in for x and have the function not get destroyed by it? I can put in any number I want in here and it won't be a problem. Any number I want and it won't be a problem. I can put in 457,000, it's not a problem. What would cause a problem? What would cause a problem is if you ever have a function like this. Do you get how if I used a big negative number for x that it would cause a problem? That's the kind you got to watch out for, is square roots. And the other thing you got to watch out for is things that have something in the denominator, like this. Do you get that there's something that could mess up my denominator? Remember how you don't want the denominator to be 0? Because it's not possible? Do you get if I put a -2 in there, it's going to cause that problem? So this one's domain is every single number in the world will work except what? -2. So the way I would write that then is I could say all reals, and you can use a big capital R with a double bar on it for reals because it's just shorter than writing all real numbers. Okay, so you could just say all the real numbers work except x cannot be -2. Maybe you should write that one for yourself as an example. This is a function, and its domain is all real numbers where x is not -2. So I'm hoping you're getting the idea that if I had, like, there's two things. There's the red thing and the blue thing. One of them's totally fine, and one of them's totally impossible. Which one's totally fine? The blue one. You can have 0 on the top. That's not a problem, because 0 divided by 5 is like having 0 cookies, dividing it amongst 5 people. That happens all the time. It's happening right now. See, there's 5 of us. I don't have any cookies, so how many do you get? 0. Okay, it works fine. Okay, it's not 1, it's 0. In your dream imagination world, it's 1 cookie, but you don't get any cookies. It's 0. Okay, this one, on the other hand, is I have 5 cookies, and I want to divide them up amongst 0 people. There's nowhere to give them. It's impossible. It's an error. In fact, your calculator will say that. And in fact, it'll say error, and it might even say domain on it. Let's try it. Grab a graphic calculator and try 5 divided by 0. I just want to know which error it gives you. Does it say divide by 0? Okay. So it's telling you that's an error. You can't divide by 0. Try 0 divided by 5. And I bet you it just says 0. All right. Okay, so the point here is we're watching out for this situation. This situation is bad. We don't want a 0 on the bottom. So I'll give you a couple more examples. What if I had this? You get that there'd be 2 things that could make my denominator be 0 now. So now I would say all real numbers are okay in this function. Anything will work at all except, this is all real numbers, except x cannot be -1 and x cannot be what? 4. Those are the 2 things that'll mess it up. That would be your answer for the domain. Okay. Now, they might ask you to do this with interval notation, which makes it a little harder. But it's definitely not a hard problem still. I go like this. Here's -1. It can't be that, and it can't be that, but it can be everything else. See how I'm making a number line first? Now, do you get how I would say it go from -infinity to -1, and it can't be -1, union with -1 to 4, and then starts up again at negative, wait a minute, I have my -1 in 2 spots, that's weird. That's a 4, it looked like a -1 to me, sorry. Okay, -1 to 4, and then 4 to infinity there. So obviously, pain in the butt, but sometimes the directions will say, give your answer in interval notation. And if it does, you got to do it that way. It means the same exact thing. Everything's working except this spot and this spot. It's just a harder one to write. I like this way because it just kind of flows for me. All real numbers work except this one and this one. So I'm accepting this answer unless they specifically have told you to write your answer in interval notation, which could happen on the test. All right. Now let's try one more situation. That's where you got square roots. Square root of x plus 5. One thing that's key here is that 5 is not, negative 5 is not going to cause a problem. Before, we didn't want the denominator to be 0, so a lot of kids just start thinking, oh, so it can't be negative 5. Actually, negative 5 is okay here. Because do you get it's just going to be the square root of 0? And that's not a big deal. Calculator can do that. You can do that. What is the square root of 0? 0. So that's not a problem. Negative 5 isn't the problem. But if you draw a number line like this, do you get how negative 5 is right here? And it's okay. It's not a problem. But, and where else can work? What other numbers could be okay? Anything bigger than that. So all these numbers here are also okay. So my domain would be like this. So a domain, usually you write down, here's the numbers that will work. So I would say, this is my domain. All the numbers that are negative 5 or bigger are okay. And if they had something like negative 6, you can just test it and see. Watch, it doesn't work. I get negative 1 underneath the square root, and that's not real. Even though we can figure out what that means with the imaginary numbers, we don't want to mess with those. We just say we only want the real numbers that work. So final answer on this one is negative 5 to infinity. Or if you wanted to say it with all real numbers, you'd say all real numbers where x has to be what? You don't ever say not less than, because that's a weird sign. Don't do that. You want to say all reals where x is what? Bigger than negative 5. That's a good answer. That's a good answer. Oh, sorry, you're right. There's a bracket down there. You're right. Negative 5 works, so it's okay. All right. So let's do one, and I think you'll get the idea that you're not going to have much trouble with these. So y equals square root of x minus 7. Be careful with that one. Figure out what numbers can work. And then what you're answering then is, what's the domain of this function? Give it a shot. Write the problem down and then write what you think the domain is. And just write a D, and then you say, you can do the all reals thing. Looking at the ends of your hairs are not going to give you the answer. Please write this answer down. That was obviously only directed to one person. I don't want to say. All right. Hopefully you said either all real numbers work except. And the way I do this is I draw myself a little line, and I'd say, what's the key number here? 7's the key number. And 7 still works, right? 7 works. But do I want numbers that are bigger than that to make this be okay? Yeah, so it's like this again. So these are the numbers that work. So I'd say all real numbers except x has to be bigger than 7. No, or equal to, sorry. Or equal to 7. On the test, unless the directions say otherwise, you could write this. And you need to have the all real thing in there first. You couldn't just say x is greater than or equal to 7. You have to have this all reals. Big R. If you'd rather, you can say 7 to infinity, where 7 works. Both are good answers. Okay? Anybody have a question about that? All right, then let's do the harder kind. There we go. It's not super hard, but some people get it wrong. Give me the domain for that. So I would always start my answers this way, all real numbers, except what? what you're answering when you're answering a domain is what numbers work. It's as if I told you what numbers would work for this. And you would say, all the numbers work except x can't be this, or x is bigger than that, or whatever. So what in this case, what would we say? X cannot be what? Can't be 0. That's the key one. A lot of people won't have noticed that. And x cannot be 4. Why can't x be 0? Because if we put a 0 here, it won't matter the other part, because 0 times anything in here would still make it 0. Yes. You're asking, so? Why not 4? Because both 0 and 4 will mess it up. We've agreed that if you stick a 0 here, the whole thing will crash. But if I stick a 4 here, that also makes that be 0, and the whole thing will crash. So both of them will make it crash, both that and that. So all the real numbers work except this can't be 0 and this can't be 4. And if it's not 0 and it's not 4, everything else in the world would work. All right. We've talked about, oh, here's the like piece de résistance. See if you can handle this. Can you imagine that being an R3 on a test? I can. So if I were you, what I'd do is make myself a number line, because this is probably the easiest way, is to think, well, what numbers would mess this up? And then you like cross them off on your number line. Say, well, this would mess it up, and this would mess it up. All those kind of numbers would mess it up. So just do one little step at a time. Would you agree that 4 would mess it up? Okay. And would you agree that -7 would also mess it up? So those are clearly important points. -7 and 4. I'm going to put them on my number line. And they would mess it up, which means they can't be 7 and or -7, and it can't be 4. Now, what's the key spot on top? 5. And can it be 5 or not? Yes, it can be 5. And now I really should just test intervals. But if I just think about it carefully, I could say this number right here will tell me everything about whether things work or not. Do you get how that things need to be bigger than 5? All the numbers over there are going to work. How about between 4 and 5? This is where kids would get it wrong on the test. They'd be like, well, I thought everything was supposed to work over here. Everything except this. But I just said 2 seconds ago that things had to be bigger than 5. You know what I'm saying? So all those red areas won't work. So that won't work, and that won't work, and that won't work, and this point wouldn't work, and this point wouldn't work. So what's my final answer? What are the things that work? Things that are 5 or bigger. 5 to infinity is the final answer. How many had that one right? Excellent. That was a tough one. All right. Now let's talk range. Do you know what that shape should be, generally? Parabola. Moved where? Up 5. So if you know it's a parabola, it's been moved up 5 generally, doesn't it look something like that? Now, can I just do my domain and range from the picture that I have in my head? Absolutely. I can't, like, outlaw you from having pictures in your head. So, in fact, on this kind, I would do it that way. I wouldn't try to do something complicated algebraically. I would just say, what's the domain and range on this thing? Well, I'm going to look at the picture in my head and say, all right, domain is this way to this way, so it's -infinity to +infinity. What does that imply? That implies everything works. Do you get how you can't screw this up by putting a number in there? There's not a problem. I can put any number I want and it'll work. Okay, so my domain's this. The range, you pretty much have to use a picture. Okay, so I've got my picture now, and now I'm doing range. I can say it's going to go from something to something. And range is how low does it go? That goes from 5 to how high does it go? Infinity. And 5 works, right? Because can I get to 5 on this? Yeah, if I put in x to 0, I get 5. So 5 works. So there we go. There's my domain and range. The moral of the story is we won't give you any domains, sorry, ranges, unless you can do them with a picture. So there's a few pictures you have to be able to do in your head. Can you picture what shape that is? If you don't know, then you need to make a list for yourself of these main shapes. The absolute value one, that's a V. Make yourself a little sketch. That's a V. If it's squared, that's a parabola. If it's square root, that looks like that. Okay, those are the main ones you have to know. Hopefully you already know them. So I can know that's a V shape. And where is the V? Well, it's been moved. Which way? Up 7 and right 4. Now, can you generally tell me my domain? Negative infinity, positive infinity, right? It's just left to right. And then can you generally tell me my range? Well, it goes from here, which is 7. Yep. That's how far up it was. To how far will it go up eventually? Infinity. So my range would be from 7 to infinity. And my domain was from negative infinity to positive infinity. All right. Last concept is just, is it a function or not? Remember the vertical line test? It's really easy. Does that pass the vertical line test? Hey, just take a vertical line, which is a straight up and down line, and will it ever touch this function twice? Nope. So then it passes the vertical line test, so it's a function. Give me something that wouldn't pass the vertical line test. Well, a circle. What if your graph was this? You get how it doesn't pass the vertical line test? Because it hits twice with my vertical line. So if I'm inputting a number like, let's say, 3 here, do you get how it's giving me 2 answers? 3 is both 1 and like 7 or whatever that is. Okay, so it doesn't pass the vertical line test. So I can't tell you all the possible things that they can give you, but a circle's a common one. What if they just go like this and then it comes back on itself a little bit? It won't be a function then. If it's not a function, it's called a relation. All right. Don't worry about, I don't think we even asked you for that word, but since you asked. All right. So that's a really easy part. Is it a function or not? Just do the vertical line test. Just a little FYI, if you've never thought about this, doesn't it seem logical? If there's a vertical line test, there might be a horizontal line test. There is. And you'll be doing that later on this year to tell if something has an inverse or not. So the vertical line test tells you if it's a function or not. The horizontal line test tells you if it has an inverse or not. Not all functions have inverses that are functions. Okay, that's just a little preview of something you're going to learn in the future, and research shows if I preview it, you'll get smarter when the time comes. So we'll see if it works. All right, this one. Do you remember this function? It's called the rational function. Y equals what? Close. 1 over x. Yes. Yeah, that one's another one you're going to see again. Y equals 1 over x. That's another parent one I would know if I were you. Okay. Then, let's say I take that and want to move the whole thing to the right 3. Remember how if you put stuff down by the x here, that it makes it go to the right? Okay, and it does. That would take this whole thing and move it to the right 3. So then I take this, move it over 3 spots, and there's my new function. Those dotted lines, those are lines you would never touch. They get closer and closer to those, but never touched. Do you remember the name for that? Asymptotes, that's right. The dotted lines are called asymptotes. So those are not actually part of the function. You just draw them to like help you figure out where to draw the real function. The real function is the red thing. So tell me, does this pass the vertical line test? Yes, it does, because in the one spot where it looks like it might touch, you're right on that asymptote line. You know what I mean? So, right there, yes, never touch your asymptote. All right. So, if you are testing, passes, oh, I'm getting nervous, but then right when it gets to here, it's not touching it at all. Okay? So, it passes the vertical line test. So that is a function. And it's the y equals 1 over x, or the rational function stuff. All right. So quick rapid fire. Does anything in the world work in this? Or can you mess this one up? You can mess it up. So its domain is not unlimited. Its domain is all real numbers except can't be -2. Good. How about this? Can any number in the world work? No, because you could screw it up by putting in a number that makes it negative underneath the root, right? What's the key moment? The key moment is where this equals 0. So you'd have to set this. 3x minus 5 has to equal 0. So 3x has to equal 5. So x has to equal 5/3. That's the key moment. If I put 5/3 on here, in case you don't know, that's like 1 2/3. Okay. Does 5/3 actually work or not? Be careful on this. Kids screw it up all the time. Yes, it works. So I'd fill in a darkened circle there. Now, generally, do you get I can put in big numbers and I'm going to be all right? So that must mean that the ones that go to the right work. So there's my domain as a picture. If I asked for it in words, you could say x is greater than 5/3, or equal to, sorry. Or you could write all real numbers where x has to be bigger than or equal to 5/3. Or you could say 5/3 to infinity where it can be 5/3. So the only thing that made that one more complicated is you had to figure out what makes this 0. The ones I gave you before were like baby ones, were like this, where you'd say C5 will make it 0. And that makes it really easy to see what the key point is. So if they just throw in something like this, just set the whole thing and then go. In this case, it's 5/2. All right. Moving on. This one. Does your gut say that there's potential numbers that could screw it up? Yes. Does this have anything to do with it? No, because I can put in any number in that and it won't screw it up. So I just have to look at this. Would you please solve this and tell me what the domain is on that one? I think this is one of our last examples. So fight through one more with me. So you're setting -2x plus 3 equal to 0, and you're solving that. The negatives cancel each other, 3/2. But that's not the answer. So often kids will get that and then say, what did I do wrong? That's not a domain. It's just a number. The domain is supposed to be all the numbers except this. So all real numbers except x has to be, is it bigger than that or smaller than that? All right, I better test now. See, this is where it could get more tricky. So I go, here's 3/2. Because it was negative on the top and the bottom, and then it canceled up. Okay. So now, does this work? Yes, it's okay if it's 0, so it works there. Now, here's the thing. When it's not just automatically obvious to you whether it's the ones to the right or the ones to the left that work, just pick something kind of biggish and stick it in and see what happens. Let's try like 5 and see if it works or not. If I put in a 5, do you get how it's going to be a problem? Because I'll have -10 plus 3, which would make -7. You see how it doesn't work? This is testing points again. This is what most of you got wrong on the algebraic test. Because you'd get your number line, and then you didn't know where it worked and where it didn't. Okay, so we got to get better at this. If this is a 5 that I'm testing, I stick my 5 in, and I see what the answer is. It's -10 plus 3, which is square root of -7, and that's a problem, and so that doesn't work. And so it must work over here. So there's my domain this time. Another way to write it would be -infinity up until 3/2, and 3/2 works. Any questions on that? Yes, sir. Nope. That's a good way. I strongly recommend it, but that's not the answer. Yep, you have to write it this way or that other way, all real numbers, except x has to be less than or equal to 3/2. The only problem with that is kids forget the all real numbers part, and then you have to get it wrong, because that's a domain. It has to have that aspect of including everything. And this does because it talks about negative infinity. This needs it's all real numbers. Just if you remember the big R, it'll be fine. But kids forget it. All right. I think range without a graphing calculator. Do you get that this is just a V shape? And if I stretch my V, do you get it doesn't really matter. It's still its domain and range aren't going to really change from that at all if I stretch it. But that +1, that just moves it up a little bit. So there's my picture that would be in my head, and I can find the range from the picture that I can have in my head. And the range would be from the lowest to the highest. What's the lowest it would ever go? 1. To the highest it would go would be infinity, so 1 to infinity, and it can be 1. There we go. All right, that's how you do those. I think that's enough practice for now. Yeah, let's get you your worksheet.